Hello everyone, my name is Jinrong Zhang. The topic of my presentation today is feasibility of urban grey water reuse in manufacturing industrial post-treatment with microfiltration. It is mainly divided into four parts: background, introduction, methodology, and conclusion. First is the background. As global water resources crises occur, the regional use of water resources is important even in manufacturing. Using recycled water greatly reduces the strain on water resources. Then is the introduction. What is microfiltration? It's a filtration technology that uses the static pressure difference at the driving force and uses the screen effect of the screen-shaped filter medium membrane to separate. What is grey water? Grey water refers to wastewater that is not polluted by stool in the home or office building and accounts for at least 50% of the total household water consumption. The project intends to explore the feasibility of using microfiltration technology to treat urban grey water for reuse in manufacturing, and the objective of this study is to identify a potential sink of grey water in Australia and thus ultimately reduce the centralized water demand in manufacturing. Next is current practices and limitations in grey water reuse. Grey water in its treated form has found usage in multiple sectors around the world. For instance, grey water from community is used for subsurface irrigation in Mali, and in Costa Rica, reeds are irrigated by treated grey water. The limitation of reusing grey water are mainly associated with three aspects. Firstly, health risks could be caused by pathogenic microorganisms contained in the grey water. Furthermore, pollutants like sodium surfactants could cause serious environmental problems. The last limitation is high cost. In order to produce high quality water, high capital demanding processes are indispensable. The next part is methodology. First, there are three major aims that our study intends to serve: assessing water quality requirements of manufacturing processes, evaluating effectiveness of microfiltration in treating grey water to desired water quality, checking if treated grey water meets industry water requirements. To assess different water requirements, the first step proposed is to find out what requirements could be used by various companies near a settling area. Shang 2013 pointed out the basic requirements in his article: raw water processing and wastewater treatment. In order to determine the efficiencies of microfiltration and grey water treatment, this study chose random sampling to collect samples at the inlets and outlets of microfiltration sectors on the plants, with the total numbers of samples is large enough to reduce systematic errors. Then, this study intends to compare the static inferences with manufacturing guidelines, triggers, and assess the variability of population data to ensure the output from microfiltration plants is suited for manufacturing needs. Finally, I want to talk about the conclusion. The grey water reuse can meet the requirements of the manufacturing industry for water resources. Practice has proved that the use of microfiltration technology can effectively treat grey water to a level that is useful for many applications. However, there are still some limitations. Firstly, there is no water quality guideline in the manufacturing industry. Then, there is a lack of information in different manufacturing industries, and the high cost of microfiltration technologies are barriers to this research. Finally, because of the complexity of grey water, sometimes it is difficult to achieve the effect of reuse only by microfiltration. According to previous literature and experiments, microfiltration has a significant effect on the treatment of impurities and turbidity in water. Hence, this proposal demonstrates the potential of microfiltration technology for grey water reuse in manufacturing. Thanks for your attention. Bye.